Welcome to this lesson. In this lesson, we are going to look at some sample questions. In total, we are going to look at 12 total questions. And in this lesson, we are going to cover 6. And in the next lesson, we are going to cover the remaining 6. So let's get started. So the first question here is around OCI networking service. And the question says, which component of OCI networking service provides a private connection between a VCN and an on-premises network? So the keyword here is private connection between VCN and on-premises network. And you get 4 options, and these are all gateways: Internet Gateway, NAT Gateway, Dynamic Routing Gateway, also referred to as DRG, and Service Gateway. So I'll give you 5 seconds, think about what is the right answer, and then we'll go to the next slide. Alright, so the correct answer here is DRG. And you can see the explanation on the screen there. DRG is basically a component, virtual router of OCI networking service that provides a private connection between a VCN and on-premises networks. And using this, you can establish connectivity between on-premises and the cloud for hybrid scenarios. And you could use, next slide actually basically is from the coursework, and we covered this as part of the networking module. And you can see here we have a virtual cloud network, and in this VCN we have 2 subnets, and there is a dynamic routing gateway, the DRG, which basically helps you connect to your on-premises network. And you could use DRG for site-to-site VPN connectivity, or you could use it for something called Fast Connect. Now you can also use DRG to connect 2 VCNs in the same region or different regions. But this particular question is specifically asking you for on-premises connectivity, and that's basically the gateway which is used is Dynamic Routing Gateway. Internet Gateway is used for bidirectional connectivity to the internet. NAT Gateway is used for unidirectional connectivity to the internet, and then Service Gateway used for private connectivity to services running in Oracle Services Network, as is being shown on this particular slide. All right, question 2 is around what's the primary purpose of a network security group, also referred to as NSG, in Oracle Cloud Infrastructure Networking Service. You have 4 options. I'll give you 5 seconds, read through it, and then we'll look at the right answer. Alright, so the correct answer is to control traffic flow between specific resources within a VCN, and I can read the explanation there. NSG is basically designed to control traffic between specific resources. It provides a more granular level of control compared to security list, enabling users to apply security rules to individual resources such as instances or load balancer. Next slide actually I'll have taken from the lesson. I'll go through this in a little bit more detail. But you can also eliminate, if you don't know this answer, you can eliminate some of the other options. Like the first option A here, routing control is done by route tables, not done by network security groups. Private connectivity between a VCN and on-premises network, we just saw in the previous question, that's DRG. To connect a VCN to the public internet is basically through Internet Gateway. So if you didn't know this answer, you could eliminate some of the other choices, and you could add the correct answer. Now this again is from the coursework, and you can see here we are using NSGs, which are nothing but kind of virtual firewall, and it contains firewall rules. And you can see this instance has NSG, has a network security group denoted by NSGA. This one has NSGB, NSGC for other instance. And this is how NSGs work. You can use, for example, if this is a web server talking to a database server, you could define its ingress, incoming, or egress, outgoing traffic using the NSGs here. So literally you can be more granular compared to security lists, because security lists actually apply to a subnet here, and all the instances in that particular subnet would actually use the same security list. But in case of NSG, you can be more granular, and you can control the traffic flow between specific resources in a VCN. So for example, here, a web server talking to a database, you could leverage capability like network security groups. Alright, so changing gear, let's move on to the second topic, which is around compute service. So there's a question here which says, what is the term used to describe the combination of an instance's shape, base image, and metadata in Oracle Cloud Infrastructure Compute Service? Give you 5 seconds. And we'll look at the right answer. Alright, so the correct answer is instance configuration. And in OCI, basically instance configuration is a predefined configuration that includes the instance's shape, base image, and metadata. It allows users to quickly create new instances with the same configuration, streamlining the deployment process. So again, we covered, and by the way, all these other options don't exist in OCI. They are kind of made up. So there is nothing called instance template, there's nothing called instance profile, and there's nothing called instance specification. So these are all distractors, kind of, but the right answer is instance configuration. Now again, we discussed this in the compute module. We have a lesson on auto scaling, and there we actually talk about instance configuration. And instance configuration can be used in an auto scaling context, but you could use it in a general context as well. Doesn't need to be part of auto scaling necessarily. So what is being shown here, you take a running instance and you create something called a configuration, which is kind of a template, or a kind of, I would say, template, which has your OS base image, metadata, shape, etc. And using this configuration, now you can spin up many more instances, and you can create what is called as instance pool, because in a pool, all instances are kind of homogeneous. So you kind of leverage a capability like instance configuration to create instance pool, which is basically more than one instances, which you could use for auto scaling. Now this is one context, but you could use instance configuration just for any other purpose as well. If you want to kind of have a gold image and you want to keep that image consistent for all the other users to leverage, so you could actually create an instance configuration. Alright, so the next question on compute is, what is the primary purpose of Oracle Cloud Infrastructure Functions? Functions is a serverless offering. So let's give 5 seconds. We'll look at the right answer. Alright, so the correct answer here is to execute code in response to events or HTTP requests. And functions, basically, the primary job is to run code in response to events or HTTP requests. It's a serverless platform that allows developers to build, deploy, and run applications without the need to manage the underlying infrastructure. And in the compute module, we do cover compute service, and we do cover virtual machines, bare metals, and different things, different features they have. And then we do cover containers. We cover Oracle Container Engine for Kubernetes. Okay, we cover container instances, and then we also cover functions. So these are different kind of, if you think about compute as kind of a continuum, these are the different points on that continuum. So sometimes, you really need to understand where to use what capability. So compute could be used to run anything, right? Where you want to control the operating systems. It could be non-containerized workloads, Windows workloads, legacy applications. Basically anything you want to run, you could run on compute, any kind of workload. Nowadays, customers are running containers primarily, right? So if you are running containers, we basically have two capabilities or two offerings for containers, running containers. The first one is the container engine for Kubernetes. Okay. And in here, basically we give you a managed Kubernetes service. And also within this service, we have two options. One is called managed nodes, and one is virtual nodes. And the idea here is managed node basically give you the control and flexibility. So you manage your Kubernetes nodes, your patching and scaling and all that. In case of virtual nodes, it's basically a serverless offering. So if you want a hands-off approach, you would go for virtual nodes. If you want more control, you can go for managed nodes. So there's just two different kind of options regarding the kind of their approach to management. And then there is container instance, where you want to run containers, but you don't want to run something like Kubernetes. It's too heavy for the application you are running. Maybe it's a small website you want to containerize, right? So that option is there, where it's again kind of, you don't have to manage the underlying infrastructure. You don't need to run Kubernetes. We'll let you run containers without managing an underlying infrastructure. And then on the very other side is functions, where you're basically running code. It's a complete serverless infrastructure, and this code could be run in response to an event or a HTTP call, right? And you just provide the code, and you don't care about the underlying infrastructure, and the code is run. So this is kind of the continuum for compute. Compute you could use to run anything. Containers, you have OK and container instances, And then for serverless offering, we have functions where you can just run code without worrying about underlying infrastructure. And we cover all of this in the compute module. Let's change gear and look at storage. So the question here is, what feature of object storage service enables users to automatically move objects between storage tiers based on predefined rules? Let's take 5. We'll come back to the right answer. Alright, so the correct answer is object lifecycle management. And the basic idea here with object lifecycle management is, we covered this in the storage module, is you can move your objects from different tiers. So you can move objects from the standard tier to archive tier, and you could define rules saying that move objects after 30 days or automatically delete archived objects after 180 days. The whole idea is to save costs by doing this, and this capability is there with the object storage service. The next question is around block volume service, and it asks as to which performance level is not available in the block volume service. You will have many questions where we'll have something like it's not there, or this feature is not supported or available. So just pay attention that it's asking three options are correct and one option is incorrect. So just pay attention to that. Take 5, we'll come to the right answer. Alright, so the correct answer here is the tier which is not supported is low performance. In fact, there is no tier which is called low performance. There is a tier called lower cost, but there is nothing called low performance. And we covered this in the theory lesson for block volume. And again, if you see for block volume, we have multiple tiers. There is something called lower cost, which is good for large sequential IOs workloads. There is a balanced tier. There is a higher performance tier, and then there is a ultra high performance tier. And you can see the IOPS, input output per second operations supported, starting all the way from 2 IOPS per gig all the way to 225 IOPS per gig for ultra high performance. We covered this in theory, and we also show this in one of the demos. So hopefully this was a quick lesson on the kind of sample questions you can get for topics around networking, compute and storage. The idea again here is you have to understand these services and understand their use cases and understand some of the components from a very high level perspective. There is no requirement to have practical hands-on experience. None of these are scenario based questions, but you definitely need to understand the services, what they do, what are the use cases, and some of the high level components. I hope you found this lesson useful. Thanks for watching.